So for today's lesson, we're going to continue reviewing what we covered yesterday, the trig identities. Many of you have reached out to me via email asking me to go over the homework again with you guys and to go over the lesson. I'm going to tell you this right now. This stuff does get a little confusing. It's not that it's difficult, it's just that you guys aren't used to seeing math in this way, if that makes any sense. So I put these up on Plus Portal. So I believe it's under the files section of Plus Portal. So you have this, so you can either print it out for yourselves or write this down in your notebook. So I went ahead and wrote you all the reciprocal identities and all the quotient identities, and I just took a screenshot of this on Plus Portals. You're also going to see the Pythagorean identities. We're going to cover those tomorrow in tomorrow's lesson. So the reciprocal identities are as follows. Sine of x is equal to 1 over cosecant x, or 1 over CSC x. Cos of x is equal to 1 over secant of x, or 1 over SEC of x. And tan x is equal to 1 over cotan x, or 1 over COT x. And then cosecant, CSC, x is equal to 1 over sine of x. Secant, SECx, is equal to 1 over cos x. And cotan is equal to 1 over tan x. Those 6 are your reciprocal identities. Now you guys also have something called quotient identities. That's only with tan and cotan. So for tangent, you have 1 over cotan x, or you can also write it as sine x over cos x. Cotan x is equal to 1 over tan x, or you can write it as cos x over sine x. With these quotient identities, it could be helpful, so when we go ahead and we'll go over some of the problems, you can either rewrite tan of x as 1 over cotan x or sine x over cos x. And then you can also write cotan x as 1 over tan x or 1 or cos over sine of x. The reason being, like, you can have multiple ways to write tan x or cotan x, so we're going to go over that. So you kind of have some options which one you want to use, and depending on the problem, we're going to go over which one you're going to end up using. So let's go over the homework right now. So for the first problem, I give you tan of theta times cos of theta. Now going back on that formula worksheet I gave you guys, tan of theta can also be written as 1 over cotan of theta or sine of theta over cos of theta. If you guys are concerned, oh my god, in the formula sheet we have an x and now we have a theta, that's completely fine. You can use x, you can use theta, you can use alpha, you can use beta, whatever you want to use, as long as it stays sine, cos, tan, and so on. You could change the x to become a theta, you could change a theta to become an x, and vice versa. So tan of theta can be written two ways. You can either write it as 1 over cotan theta or sine of theta over cos of theta. For this problem, we're going to choose to use sine of theta over cos of theta. Why would I want to use that? Well, because in this original problem, it's like you got to think a couple steps ahead, but while still using that original problem. In the original problem, you're multiplying it by cos of theta. Well, if I use 1 over cotan theta, there's no way I could cancel out this cosine, so that's why I'm going to go ahead and use sine of theta over cos of theta, because now I have sine theta over cos theta times cos of theta. Now what happens? Now we go ahead and multiply, so you can cancel out like terms, so this cos and that cos both cancel out, and you're left with sine of theta. So your answer for this problem is sine of theta. In problem 2, I gave you tan of theta times cosecant of theta. Now, tan of theta, right here I wrote tan of x, that's completely fine. You could write it in two ways. It could be 1 over cotangent x, or it could be sine x over cos x. And we're going to use this one, sine x over cos x. And then I also give you CSC of theta is equal to 1 over sine of theta. So it's always, I would always recommend, always try to replace tangent with something, and then tangent most of the time, I would say like 90% of the time, you're going to replace it with sine over cos. And then anytime you see CSC, SEC, or COT, go back and figure out what its original identity is. So CSC is equal to 1 over sine. So now we just go back in and substitute in. So instead of writing tan of x, we're going to write sine of theta over cos of theta, and then times, and instead of writing CSC of theta, we're going to write 1 over sine of theta. Now we go ahead and multiply, and we could cancel out our like terms. So you could cancel out the sines, and we're left with 1 over cos of theta. That technically is your answer, but if you look at those identities on that sheet that you guys have, 1 over cos of theta is equal to secant of theta. So yes, your final answer could be 1 over cos. The best answer in this case is secant of theta. On a quiz or a test, if you guys get up to here, I'll give you the points, but just know that this is the best answer. Secant of theta is the best answer. Now we're going to skip over 3 because I didn't realize I kind of jumped ahead a little bit. We need the Pythagorean identities to do that. So we're going to skip 3. We're going to go to number 4. So in 4, I give you sine of x times the secant of x. Well, sine of x is going to stay that. We don't have to worry about flipping that one or anything. So what is secant of x? What is that identity? Secant of x is equal to 1 over cos of x. So we can write our problem now. Sine of x times, and in place of secant of x, we're going to plug in 1 over cos of x. Now we go ahead and multiply, and you get sine of x over cos of x. Looking at your identities, that now simplifies to tangent of x. That is the best answer for this problem. Yes, you can give me sine x over cos x. The best answer is tangent because you can replace sine x over cos x with tan. In 5, I give you guys cotangent x times secant of x. Now you got to think ahead. What can I replace cotangent with? Cotangent can be either be written as 1 over tan, or in this problem, how it's going to help us the most, cotangent is equal to cos of x over sine of x. How can we rewrite secant of x? Secant of x can be written as 1 over cosine of x. Now we go ahead and plug those back in. So instead of writing cotangent x, we're going to write cos over sine. Oh, there should be an x over here. I must have forgotten it. That's okay. So it should be cos x over sine of x times, and secant is, instead of writing secant, we're going to put 1 over cos x. And then we can go ahead and cross out our like terms. So our two like terms are cos and cos. So now we're left with 1 over sine of x. And then we go ahead and use our identities. 1 over sine of x is equal to cosecant of x, or CSC x. So those formulas I gave you guys on the first slide, or first or second slide, kind of work both ways. They go back and forth. What I mean by that is, I'll go back over. So here you can either say, 1 over sine of x is equal to CSC x, or CSC x is equal to 1 over sine x, and so on, back and forth. You could say cos of x is equal to 1 over secant of x, or you could say 1 over secant of x is equal to cos. And then the last one, I give you guys sine of x times the cosecant of x. Don't worry, I was checking some of your guys' homework. You don't always have to replace every single thing with one of the identities. My advice to you guys is to not worry about replacing at this, like you're not always going to need to replace sine, cos, sine or cos, you're not always going to need to replace. Anytime you see CSC, SEC, or COT, I would always go ahead and replace that with something. So this problem, we don't have to replace sine with anything. What could we replace cosecant or CSC x with? CSC of x from that chart is equal to 1 over sine of x. So now we go back and rewrite our problem. So now we can rewrite sine of x times, and instead of writing CSC, we're going to put 1 over sine of x. Cross out our like terms, which is sine, and your answer is 1. The reason we don't replace sine, because if we did this, sine would be 1 over CSC. That gets us, that essentially doesn't really get us anywhere if we go ahead and replace the CSC. That doesn't like really get us around too much. So when you guys have, not all the time, for most of these problems, when I give you sine or cos times either SEC or CSC, just replace one or the other. You don't need to replace both of them. Let's try this new example. Sine of x times the secant of x over tan of x. This one's a lot bigger, so you kind of got to break this one down step by step. Like I said, don't replace sine of x with anything. Secant of x can be replaced with 1 over cos of x. So we go ahead and do this now. So we have sine of x times, instead of writing secant, I'm going to replace it with 1 over cos x, and all divided by tan x. We go ahead and do the multiplication. Sine x times 1 gives us sine x over cos x, all divided by tangent of x. Using that formula chart I gave you guys, sine x over cos x is equal to what? It's equal to tangent. So now your answer is tan over tan, which simplifies down to 1. So your final answer for this problem is 1. Let's try this example. Tan x over secant of x. Now this one. Tan x is equal to sine x over cos x. And we can replace secant of x with 1 over cos x. So we go ahead and do that. So we have a giant fraction here now. So in the numerator, we have sine x over cos x, all divided by 1 over cos x. Now you're going to be asking me, how the heck am I supposed to solve that fraction? Well, when you have a fraction in the bottom, it's like you're multiplying by the reciprocal of that fraction. So take whatever's in the denominator and flip it. So we're going to flip it, and when we do that, we're essentially multiplying by it. So now, instead of having sine x over cos x all divided by 1 over cos x, now you have sine of x over cos of x times cos x over 1. So now we can go ahead and multiply, or if you want to do the first thing, cross out like terms, go right ahead. Like terms here is cos x and cos x. So now we're left with sine x over 1. So your final answer for this problem is sine x. Now what happens if I gave you guys sine x times the cotan of x times the secant of x? It's okay. Now I'm just adding some more identities. It's like I'm just making you guys just multiply a couple extra numbers. So don't replace sine x with anything. Keep that alone. Cotan. What can you replace cotan with? Well, cotan is cos x over sine x. What can you replace secant of x with? Secant of x is equal to 1 over cos of x. Well, it has no s, but it's cos of x. So now we go ahead and plug just sub it back into the original problem. So we do sine of x times, instead of cotangent, we write cos x over sine x times, and instead of secant of x, we write 1 over cos x. So now we could go ahead and cross out our like terms. So the signs are the same, so they become 1. The coses are the same, so they become 1. So our final answer is 1. So you're kind of just essentially plugging in, and then for these ones, you're just looking to be able to cross out the sine, cos, tan, and so on. You're kind of like looking for ways to cross them out. Like once they cross out, your answer is usually always going to be 1, or one of those identities is going to be sine, cos, tan, CSE, SEC, or COT. So that's essentially what we're trying to do. We're trying to replace them and then end up canceling everything out. And let's try this final example. Cotan of x over secant of x. Cotan of x times secant of x over the cosecant of x. So we can replace cotan of x with cos x over sine x. Secant of x can be replaced with 1 over cos of x. And cosecant of x can be replaced with 1 over sine of x. So now we put this all into one kind of nasty looking fraction. So instead of cotan, we replace it with cos over sine. Instead of secant, it's 1 over cos. Instead of cosecant, it's 1 over sine. So now we could go ahead and begin to simplify. Well, in the numerator, we have two terms that are like, so we can cross out the two signs, and then we're left with 1 over sine of x, all divided by 1 over sine of x. When we're dividing by a fraction, what you're really going to end up doing is multiplying by the reciprocal. So now we have from the numerator 1 over sine of x times, and this sine x over 1 comes from this new denominator over here. So when I want to get rid of this fraction in the denominator, I got to multiply by the reciprocal. So I go ahead and multiply that. So then I get 1 over sine x times sine x over 1. The sine x is our like term, so we are left with 1 over 1 times 1 over 1, which is 1. And our final answer for this problem is 1. So your guys' homework is on Plus Portals. Make sure you guys are following directions. Remember, email it to me when you're done. If you don't get an email back from me, that means I didn't receive it. If you guys still have any questions on this, please, send me an email and let me know, and I can help you work through them. Have a great day, guys.